Alright guys, welcome back. Last Algebra 2 video of the day, thankfully, and then all I have left is a geometry video, and then I will upload all of these later, which you won't know because you're only going to see them when you see them. This is imaginary numbers. We just vaguely, remotely touch the surface of these in our book. This is on page 209 to 211. There is a chart of notes right here that is on that page that you need to know in order to do these, because these are like conversions. This is I is what we use for the imaginary number. It is represented when there is a negative number under the radical. -1 under the radical equals an I. And then there's an I squared, I to the third cubed, I to the fourth, I to the fifth. And it shows how they got the calculations by using these. And this is what their answers are. So you can see that because we're going to need those in the first part of the lesson. And these are just a wide array of problems on here. But when you get to something like I to the 7th, there is no I to the 7th here, but there is a pattern that you need to follow. What you want to do is to break that down. First of all, this is -1 under a radical, which means it's I. So I'm going to write this as I to the 7th. Then I'm going to break it down into something that's in this chart. Remember, exponents, we add them together to make that. So I could break this down to I4 plus 3, because 4 plus 3 makes 7, correct? If I look at I4, the answer to that is a 1. Okay, so that is a 1. If I take the 4 out, that's a 1 times whatever I have for I3. I3 is -I. Alright. Oh boy, I don't know why I wrote it like that. But so 1 times -I is -I, and that is the answer to I to the 7th. So you're just going to use that chart, break them into everything in that chart, and convert them. All of the answers of the ones that look like this are going to be one of these things. And I'm going to use a contrasting color because that red and that pink are clashing. So if I look at number 4, it's I to the 18th power, or -1, the square root of -1 to the 18th power. First of all, I'm going to change that to I to the 18th. And then I'm going to break that down. And it can be broken down several different ways in there. I'm going to use I, and then I'm going to go 4 plus 4 plus 4 plus 4 plus 2. Because 4 plus 4 plus 4 plus 4 is 16, plus 2 is 18. Now you could use 5, 5, 5, and 3. But I picked 4s. Why? Because the answer to I to the 4th is a 1. A plain old 1, which makes the problem so much simpler. So simply put, this would be a 1 times a 1 times a 1 times a 1. So that all would be 1 times whatever I have left, which is I squared. So if I look at I squared, the answer is -1. 1 times a -1 is just a -1, and that is my answer to the square root of -1 over 18. It's -1. So it doesn't matter. There's numbers like 21. They can give you up to like 76. You're just going to use these in the pattern to make them easy. And I suggest using the 1s as much as you can to simplify it, because everything multiplied by 1 is just 1. Okay? So that's how the first part lays out. Then they want you to multiply, divide, add, subtract. Okay, so when we do that, we got to pull the I out first. Let me move this out of the way, and I'm going to go ahead and erase these to unclutter my board a little bit. So on problem 11, when we do this, we're going to change this to where this, if there's a -1 right here, we're going to pull the negative out. That makes an I on the outside, and leave this like this, and pull the negative, or pull the negative out, which is an I, and then I have this. All right. The square root of 1 is 1, so 1 times 2i would be 2i. Square root of 4 is 2. 2 times I would be 2i. Then I'm going to multiply them, and I'm going to get 4i squared. Now, I want to look at I squared. I squared is a negative 1. So this is really 4 times a negative 1, which equals negative 4, and that is my answer. Okay, so you simplify it as best you can, but we're using this chart. If you don't know how to use this chart, it will be very difficult. All right. So on 16, that is the adding and subtracting, and it's a lot. I guess it's more difficult than if you're doing multiplication or division. So because you have to have like radicals when you're doing them, and you have to reduce them. So when we look at this, we'll go ahead and pull the negatives out. So I would get 5i radical 18 minus I radical 72. Okay? If you ignore the I, this is just like what we were doing. We need to get them in the same radicals in order to subtract them. Otherwise, we just simplify and leave them alone. So first thing I want to do is break 18 up into a square root because it's the smaller. So I can break it into 9 times 2. And the square root of 9 is 3, right? I bring that to the outside and multiply. And that gives me 15i radical 2. Now I need this to be a radical 2 in order to do the subtraction here. So I'm going to divide 72 by 2, and that's 2 times 36. The square root of 36 is 6, so it's going to come to the outside and multiply by negative I, so this will be negative 6i, and then the 2 is left in here. Let me write that bigger in case it didn't come on. And remember, when we add and subtract things with radicals, they have to have the same radical, and that just comes along. So our answer is going to have radical 2 in it. And then we do 15i minus 6i. Well, 15i minus 6i would be 9i. And we're going to leave it like that. I is I, so we could leave it like that. We wouldn't want to put it back in that. We're going to leave it alone. And that is the answer. Okay, that's about as complicated as it's going to get. I'm sure they're going to throw some stuff at you, but that's pretty much how complicated it gets. We're going to look at 19, which is multiplication, and then we'll look at 22, which is a division, and be done. So with this one, again, we're going to pull the i's out. So I will rewrite my problem as 3i radical 5 and 2i radical, well, that's not a radical, that's a parenthesis, radical 15. Okay, these are square roots, and they're 5 and 15 are not going to break down into perfect squares, so I need to go ahead and multiply them. I'm going to get 3 times 2, which is 6, I times I, which is I squared, and then 5 times 15, which I want to say 75, but I should double check that just in case, and I've lost my calculator. Yeah, it is 75, okay. Just checking to 75. Then what I'm going to do is reduce my radical. So I know that 75 is going to break up into 25 times 5. There is a square root of 25. It's 5. It's going to come out here. 5 times 6 is 30. So I'm going to have 30i squared radical 5. Now I do believe they don't want us to leave that I squared there. Let me double check, but I'm pretty positive they want that gone. Yep, they want that gone. So what we need to do, and that's not a 5, that's a 3. What am I doing here? 25 times 3 is 75, not 5. That's 125. What I want to do here is look up here for I squared. it is a negative 1. So instead of I squared here, I'm going to have a negative 1. Well, 30 times negative 1 is just negative 30, and then this is radical 3, and that is my completed answer. Okay? So although this looked very complicated to you, it's not that bad. We got one more. My battery's blinking. I hope I can get it in. This division problem. If not, it will be clipped off and put on another one. I'm going to move it up here and try to work fast, but that never works out for me. Alright, so we'll go ahead and put this in a correct division problem. That's supposed to have a negative on it. See, I'm already making mistakes. You shouldn't ever work fast in math. The regular division bar, okay? And then I'm going to go ahead and pull the I out. And then I've got to get rid of the 3 on the bottom. It can't stay there because no radical's in there. So I'm going to multiply by radical 3 on both. And 3 times 18 is 54. So I'm going to have radical 54 at the top with an I out there. And then on the bottom, I'm just going to have I. Or not, I'm not just going to have I, I'm going to have I radical 9. Square root of 9 is 3, so I have 3I on the bottom, I on the top, and I have a 54. Now I need to see if I can break 54 down into a smaller radical. So I got to find a perfect square that goes in there. I don't know. I can't think because I'm on the crunch time here. Alright, so we'll go 9 times 6. I was thinking there might have been a bigger one, but there's not. So 9 times 6. Square root of 9 is 3, so I have 3i radical 6 over 3i. Alright, 3 i's cancel out. My answer is just radical 6. Alright, that concludes this video. And have a good rest of your day, and God bless.